right now, you probably have a tab open on your browser with an AI chatbot, and it is kind of a startling paradox when you really think about it.
Yeah, it really is.
Because for most of us, this technology feels like like a completely weightless magic trick living somewhere up in the cloud. I mean, it writes your cover letters, it summarizes a 50-page PDF you didn't have time to read for class, and it just seems to do it all out of thin air, usually for free.
Right, and only about 34% of people even realize the extent to which they are interacting with artificial intelligence throughout their day.
Exactly. We just accept it as this invisible, frictionless convenience.
It does feel like magic. You type in a prompt, and like a second later, an entire essay appears.
But the illusion really breaks when you realize the physical toll of that transaction.
But what if you knew that generating a simple 100-word email using an AI chatbot essentially drinks an entire bottle of fresh water?
Welcome to the Missing Lessons, where we explain what school never did.
So true.
Today's deep dive is about the massive hidden costs of AI. Everyone talks about how AI will change the future, but nobody talks about the massive physical, financial, and human price tag attached to it right now. It is far from weightless, and as we are about to explore, it is definitely not free.
If you're enjoying the Missing Lessons, make sure to follow the podcast, leave a rating, and share it with someone who might find it interesting. It helps us create more episodes and reach more curious minds.
So, we really need to completely shatter this illusion of the cloud. We use that word so often that it tricks our brains into thinking our digital lives exist in some fluffy white mist floating above us.
Which is not the case at all.
Not even close. The cloud is heavily industrial. It is a sprawling global network of massive, windowless concrete buildings filled with rows and rows of servers.
Just blinking in the dark, constantly humming, and generating an unbelievable amount of heat.
Right. And the generative AI we are using today is fundamentally different from the traditional tech we've relied on for the last 20 years.
Because for years, the internet has basically functioned like a giant public library, right?
Yeah, exactly. When you type a normal query into a search engine, the system runs into the stacks, grabs a web page or an article that already exists, and simply hands it back to you.
Makes sense.
Fetching something that already exists takes a little bit of energy, sure. But generative AI is not fetching a book.
It's writing a brand new book from scratch every single time you ask it a question.
Precisely. And to do that, it has to calculate probabilities across billions of parameters. To understand what that means, think of parameters like the knobs and dials on a massive, complex soundboard.
Okay, I can picture that.
A popular AI model might have over 175 billion of these knobs. Every time you ask it a question, it has to rapidly adjust those billions of dials mathematically over and over again, just to predict that the word apple should probably come after the word red.
And adjusting those billions of dials for every single word requires serious computing power. So when a student uses the latest, fastest AI model to summarize a PDF, it requires physical data centers burning real gas and coal.
Yes, which is why generating a customized AI response takes about 30 times more energy than a simple internet search.
30 times.
30 times more energy. Now, multiply that by hundreds of millions of users doing it every single day. The scale of that energy consumption is staggering.
I can't even imagine.
By 2026, generative AI will consume 10 times more energy than it did in 2023. If you combine the energy use of AI, data centers, and cryptocurrency, the total power demand is projected to equal the energy consumption of the entire country of Japan.
Wait, really? An entire industrialized nation?
An entire G7 nations worth of electricity. And that is just the energy required for inference, which is the industry term for when the AI is actively answering your questions.
But there's an even bigger energy drain before the AI gets to that point, right? The training phase.
Yes, the training phase is the real energy black hole. Before an AI can answer a single question, it has to read and analyze essentially the entire accessible internet to learn how human language works.
That has to take a massive amount of power.
Just training one single model of a popular AI language system uses the exact same amount of electricity that 120 American households use in an entire year.
Wow.
And they are constantly training newer, bigger models in a perpetual arms race. Every time you hit enter, a machine does heavy physical labor, and when machines work that hard, they generate heat.
Have you ever noticed how hot your laptop gets when running a heavy program? Now imagine millions of massive servers doing that 24/7.
Exactly, stacked on top of each other in a warehouse. You can't just blow air on a room like that.
The servers would literally melt down.
They would. And that is where the water comes in. To prevent catastrophic meltdowns, these massive data centers rely on complex liquid cooling systems.
So they pump fresh water through pipes to absorb the heat.
Yes, and that heated water is then pumped up into cooling towers, where a massive portion of it simply evaporates into the atmosphere.
Oh, wow.
In 2022, just one major tech company used 5 billion gallons of fresh water strictly for cooling its servers. That was a 20% jump from the year before.
5 billion gallons. That is hard to even comprehend.
And as these models get more complex, the thirst grows. By 2027, global AI water usage could hit 1.7 trillion gallons.
Which is more than half the total annual water withdrawal of the UK.
Half the UK's water evaporating into the sky just to keep our chatbots from overheating.
And you have to imagine the infrastructure required to secure those water rights and pull that much electricity isn't just an environmental nightmare. Who is actually footing the bill for all this?
That is the second major hidden cost, the billion-dollar bubble. If you read the headlines, you would think these AI companies are just printing money.
Right, because the economic upside being promised is genuinely massive.
It is. Forecasts suggest that AI is projected to add a staggering $15.7 trillion to the global GDP by 2030. Top generative models have over 180 million users and pull in $80 million a month.
It looks like the greatest gold rush in modern history.
But the hidden financial cost of compute, the processing power needed, is skyrocketing. The average cost of computing is expected to climb 89% between 2023 and 2025, driven almost entirely by generative AI.
Wait, if these tech companies are raising billions of dollars, why are they canceling projects?
Because they are bleeding cash. These systems require highly specialized microchips called GPUs, and they cost tens of thousands of dollars apiece. A single tech company might need 100,000 of them.
It's an arms race, but the math isn't adding up.
That is exactly the gamble. Because of these crushing costs, major companies are actually canceling or postponing their AI projects. To survive, developers are being forced to shrink the size of their models.
Oh, using a process called quantization, right?
Yes, quantization. It's a highly advanced way to compress the AI, reducing its memory needs so it requires significantly less computing power to run.
It's like lowering the resolution on a YouTube video.
Mm.
If you drop it from 4K down to 480p, the image is a lot less crisp, and you lose fine details, but the video loads instantly and uses way less battery.
That is a brilliant analogy. Quantization is exactly like lowering the resolution of the AI's brain. So companies are relying on smaller, highly targeted models instead of massive, expensive ones for every single task.
Right, you don't need a supercomputer that understands quantum physics just to draft an email.
Yeah.
But shifting from the financial drains, what happens when developers rush these extremely expensive algorithms into the real world?
That brings us to the societal cost, which is arguably the most dangerous part. This is where it goes from an abstract numbers game about water to a very harsh, tangible reality about human lives.
Because AI amplifies existing inequalities, especially when applied to public services.
Exactly. We have to understand that AI is essentially a mirror. It learns by analyzing historical human data. And if our human history is full of systemic inequality, the AI absorbs and learns those exact same biases.
But people don't question a computer. It presents biased decisions as cold, hard math.
Right. And the mechanism for this bias is often hidden in what data scientists call proxy variables.
Like a zip code acting as a proxy for race or class.
Yes. It looks at a massive data set and sees a mathematical pattern without understanding the socioeconomic context. When you apply this flawed logic to things like welfare distribution or healthcare, it amplifies inequalities with terrifying speed.
And there are documented cases where this has completely shattered communities.
One of the most tragic real-world examples is the story of the Dutch tax authority. They used an algorithm to hunt for welfare fraud.
Right, they used the AI to scan thousands of files looking for suspicious childcare benefit claims to save the government money.
But the AI wasn't just doing simple math. It wrongfully targeted parents with foreign backgrounds, accusing them of making fraudulent childcare claims.
And they demanded tens of thousands of dollars in repayment, didn't they?
Yes, immediately. And we need to emphasize the stakes here. This wasn't just a computer glitch. It pushed thousands of families into poverty.
It's terrifying that an opaque line of code could take away your job or your family.
The human toll was catastrophic. It forced children into foster care, and tragically, it led to suicides among parents who felt completely trapped by a machine they couldn't argue with.
What would you do in that situation? Would you feel helpless if an AI ruined your life or fired you and there was no human to appeal to?
That specific brand of helplessness is spreading. It is rapidly entering the workplace through algorithmic management.
Oh, where AI is monitoring remote workers.
Yes, tracking keystrokes, taking screenshots, and even scanning your face to analyze your emotions and determine if you look engaged.
Creating a constantly shifting internal credit score for your productivity.
Exactly. And the really dystopian part is that there are already documented cases of people being fired by automated systems without a single human manager in the loop.
That completely strips away our human autonomy.
It does. And if the hidden costs are this high destroying families, draining water, and bankrupting budgets, who is steering the ship?
Right, who's actually writing the rules for this global infrastructure?
Right now, the rules of AI are being written by a few powerful tech giants and Western institutions.
Which means the voices of the global south are being completely ignored.
Completely ignored. And because of that, we are missing out on inclusive, holistic ways of thinking. Take the concept of kaitiakitanga.
That's a Maori term, right?
Yes, a Maori term for guardianship and the deep interconnectedness between people and the natural environment. You are an active steward of the ecosystem, not just someone extracting resources.
Imagine if that philosophy was actually embedded into the software engineering process.
They might code AI to intentionally prioritize energy efficiency and water conservation over giving you an answer a millisecond faster.
Or consider Ubuntu, a Southern African concept meaning I am what I am because of who we all are.
Exactly, valuing community over individual gain. If AI was developed with Ubuntu at its core, it wouldn't be optimized to keep us isolated and addicted to our screens.
Instead, we are risking a future of techno-authoritarianism.
Yes, where a few individuals control the global narrative, increasing individualism and atomization.
So how do we even begin to regulate something that is everywhere all at once?
You can't just try to regulate the algorithm itself. Think of it like a game of football. Trying to regulate AI as one giant concept is like trying to regulate a game of football by only making rules about the ball itself.
Because the ball isn't the whole game. You need rules for the players, the field, the referees, the whole digital ecosystem.
Precisely. You need strict laws on data privacy, robust labor rights to stop automated firing, and hard environmental limits on data centers.
It requires a massive shift in how we view technological progress.
To summarize this deep dive, AI is an ancient dream dating back to Greek myths of automatons, and it has incredible potential.
Right, from creating $432,000 artworks to spotting lung cancer better than human doctors.
But progress isn't free.
It drinks our fresh water, burns through our electrical grid, strains corporate budgets, and if we aren't careful, strips away human autonomy in the workplace and the government.
Which is why we need to start practicing what I like to call digital sobriety. We don't allow untested food or airplanes onto the market, so why do we allow untested AI?
Maybe we need temporary bans on certain autonomous systems.
Or an Energy Star rating for AI models so consumers know the environmental cost of their prompts. It would immediately break the illusion of the weightless cloud.
Here's a question for you. Now that you know a 100-word AI response costs a bottle of water and serious energy, will it change how often you use tools like ChatGPT? Let us know your thoughts in the comments.
If you enjoyed this episode of The Missing Lessons, don't forget to follow the podcast, leave a rating, and share it with a friend. Your support helps us continue exploring the topics school never taught us.
So true.
And before you type your next prompt, consider this. We are teaching these powerful machines how to think by feeding them our entire digital history, but by allowing them to consume billions of gallons of water just to fuel our convenience, are we also quietly teaching them that our natural resources and perhaps our human boundaries are completely disposable?